Boundary conditions. Boundary conditions put restrictions on the constants in the general solution of a differential equation. In other words, when you solve a differential equation, you find that there's a lot of functions that will satisfy that differential equation. Look, like in this example right here, C1 and C2 can be any constant, right? So there's a lot of different solutions that would obey that equation. Now, typically, when you set up a differential equation, it's to solve some kind of physical problem, right? And so the physical problem itself, the reality is going to impose certain conditions on your solution. Those conditions that must be satisfied are known as boundary conditions. So when you apply those boundary conditions, you'll find that not all of these, you cannot just have any C1 and C2. It will impose restrictions on what those C1s and C2s can be. So by imposing boundary conditions, you just take a subset of all the possible solutions. Okay, so this example we have right here, that's the one we just solved, right? 4y double prime plus y equals 0. Yeah. So what's our general solution? C1 e to the ix over 2 plus C2 e to the negative ix over 2. So let's remember our solution to this. Y equals C1 e to the ix over 2 plus C2 e to the negative ix over 2. Okay? What if we want y to be 0 when x equals 0? So that's an example of a boundary condition. Let's say I'm solving I have this problem. Then this is the differential equation. I need to solve that problem. And I know that if x is 0, y must be 0. So you plug it in. Okay? So when you impose your boundary condition, you're going to say y is 0 when x is 0, right? So y equals C1 e to the I x, which is 0, right? Divided by 2, plus C2 e to the negative I, and x is 0, divided by 2. What is that then? E to the 0 is 1, right? And e to the negative 0 is 1. So C1 plus C2. What are we saying then? C1 equals negative C2. The negative of each other. So if C1 is 5, then C2 is going to have to be negative 5. If C1 is 4, C2 will have to be negative 4. So in other words, if I know that y must be 0 when x is 0, I'm not allowed to use C1 equals 5 and C2 equals 6. This will obey the differential equation, but it will not satisfy my boundary conditions. So I throw out this solution. I only keep the solutions where C1 is equal to negative C2. Okay? So that's a common thing you do when you solve differential equations. Generally, you set up a differential equations to solve some kind of physical problem. And the Schrodinger equation is a second-order differential equation. And what you'll see as we go along is this is where quantization shows up in quantum mechanics. So once you solve the Schrodinger equation, when you impose boundary conditions, that's when you start to see the phenomenon of quantization of energy. Okay?